Hello and welcome to the next video of Python Bytes problem solving. In this video, we'll see how to solve a flight itinerary problem given the list of flights. In the problem for creating flight itinerary, we are given an input of a list of flights, but the list is unordered. So we have to create the correct order, and we have been given the origin of the first flight. So over here, if the origin is given A, we have to create a total itinerary and so we have a couple of conditions to fulfill when we are solving this problem. So we have to use all the flights in the list, and the flight should be lexicographically smaller. So what does lexicographically smaller means? Lexicographically means as it will come in the dictionary. So if we were supposed to solve this problem, we will have a solution saying that A to B, then B to C, and then C to A, and then A to C. There is another solution which is possible over here, is going from A to C, C to A, then A to B, and B to C. But if we see over here, this first two flights, if it was A to B and A to C lexicographically, so in dictionary the word AB will come before than AC. Hence we have to choose this order. We have to choose this order and not this one. So let me just mark it. This is the correct order to solve, and this is not lexicographically smaller. So our solution should look like this. So now let us now jump to the explanation. How are we going to get to the solution? So we have been given origin A, and now we have to choose from the list of the flights which flights a passenger can take. So if the origin is A, the options are going from A to B or going from A to C. So as we have to take it lexicographically smaller, we will choose this. How are we going to choose this? So when we are at origin A, we will create a list of with the probable flights the passenger can take, and then we will sort it. Once we sort, we will get the list in the lexicographical form, and we choose the first element of that. So we'll choose A to B, and so our first leg of the travel is going from A to B, and now our origin for the next flight is B. So, and we have to use all the flights. That is our condition 1. Therefore, once we use the flight, we can remove that from the list. So we will remove this flight from the list, and we will only have 3 flights left now to add to our itinerary. So we are at origin B, and we will choose another flight which starts with B. So the option is B to C, and that is the only option. So you see here we are doing the same operation that we did for when we were at origin A, and we are just repeating the same steps as going at B. So this way we can create a function which we can use multiple times. So we'll be using some operation called as recursive function in this problem to solve it. So we'll see how the application of recursive function happens. So let's continue with our discussion. So when we are at origin B, we chose a flight B to C, and now we have reached our destination C. And when we have used a flight, we can just remove it from the list, and then we are at origin C, and the only flight that goes from C is a flight start which goes to A. So now over here we went from A to B and then B to C. In this third leg of our travel, we went from A to B, B to C, and then we continued our journey to A. Now we are back to A, and we have only one option of flight that is left, and that is A to C, and we will add that to our itinerary. So we initially went A to B, B to C, C to A, and C to A, and now we are going to C again. So this way we have used all the flights. We have even the lexicographically small order of flight. So that is our solution, and when we return the solution, we will return it as a list form with all the elements in it. So in this solution, we will be using some of the operations that are remove of the list, then sort, and an application of recursive function. So while solving this problem, there is one more condition. If we are not able to use all the flights, we have to return. So if not all flights used, return null. So remember that we have to return a string null if we are not able to use all the flights. In any case, in any input, we are not able to create an itinerary with all the flights in the list, we will return null. Now let us see how we code this part. Let us start coding the flight itinerary problem. Before we start coding, let us read the problem statement. Given an unordered list of flights taken by someone, each represented as origin, destination pairs, and a starting airport, commute the person's itinerary. If no such itinerary exists, return null. If there are multiple possible itineraries, return the lexicographically smallest one. All flight must be used in the itinerary. So we have seen all these statements and all the conditions in our explanation, and we have also solved we have seen the logic behind how to solve the problem. And let us now start coding. So for writing this code or solving this problem, we are going to create a function called flight order, which has arguments flight list, so list of all the flights that the person has taken, the origin, and the flight route. So initially the flight route is declared as none, and we will see why, because this flight route will be used again when we are recursively using the function. So let us start coding. If our flight route is none, so this is the initial condition where it is going to be true, we will create an empty list of flight route, and in the next step we'll take possible flights that can be taken. So possible flights that a person can take from a particular origin. So now let us add our possible flights that we can take from the origin. So let us run a for loop for flight in flight list. So flight list is a list of tuples, and flight is going to be a tuple. So if origin is equal to the first element in the flight, so flight is a tuple, the first element is going to be the origin, because the problem statement says that it's origin destination. The first element is going to be the origin. If it is true, then yes, this particular flight is a possible flight a person can take from that origin. So we will basically append that flight to possible flight, and then we will, once we have taken all the possible flights, we will now check if possible flight is equal to an empty list. So if there were no possible flights, if it was equal to an empty list, we will return null, because our problem statement says that if no such itinerary exists, return null. So we will return null over here. If this condition fails, then what? Yes, then we have some flights that a person can take from this origin. So we will basically sort, because we want lexicographically smaller order of flights. So we'll sort it, and now we will select the flight that we can take. So flight taken, because if there are multiple flights possible from origin, we have to choose the lexicographically smaller. So now we have sorted list. We will choose the first flight that is there in the possible flight list. So this is the first flight. Now if the route is empty, if the flight route, this variable is an empty list, when we need to add some origin, some flight starting point to it. So we will update this flight route is equal to the origin, that is the first stop where the person was. And now we will go to the flight append. So flight route dot append the destination. So we're going to add the destination. So flight taken and the second element, and we will remove this flight which is taken by the passenger from the flight list. So flight list dot remove bracket flight taken, so parenthesis flight taken. So we have removed that flight. Now what we have to again check for the next flight. So if the flight list, if flight list, that means if flight list has some elements left, we will continue the operation. Otherwise we have reached the final destination, we have used all the flights, and we can return the list back. The flight route, basically will return the route that we have mapped till now. So this flight route variable we are going to return. So now if the flight list still exists, we will run the code again, and that is flight order Now here it says the flight list, which is the list, modified list, because we have removed the flight taken. This is the modified list, and the origin is going to be the flight taken, the variables, second place, the second element in that. And now we have a flight route, so this is not going to be none anymore, so this is going to have certain value. Now here we will check if the response, so this return, so this is return or this is return. If the return is equal to null, that means at certain place there were no possible flights. If that was returned, if it's null, then our total, the final return is also going to be null. And this is how our flight route will be mapped lexicographically, and we are going to check that all the flights are being used. So to check this code, to check this function, I have three inputs, 3 lists and 3 origins. So there is a list of flights a person has taken, and this is his origin. This was an example that we saw in the discussion, in the explanation, and this was the origin. And this is another example, which is 2 flights with a start, and we'll see the response for each of them. So let us run this code. So here we'll see the first example. It starts with YUL. So in the list, the flight that starts with YUL is this one. The only option is this. So it goes to YYZ. So let me just zoom it a bit. It goes to YYZ. So we are at YYZ. And from YYZ, there is only one more flight that can be taken, and that goes to SFO. So the third element is SFO in our route. Now we are at SFO. From SFO we go to HKO, and from HKO we go to ORD. So we have used all the flights that were there in the list, and this is our final itinerary. In this example, which we saw in the explanation, we are going to do the same. When we start with origin A, we go to B, or we go to C. But lexicographically we go to B, and from B we go to C, from C we go to A, and from A we go to C. So A to B, B to C, C to A, A to C. Over here the origin is COM. So the flight that we can take is COM to YYZ, and once we reach YYZ there is no flight in the list. So that's why we returned it as null. I hope you have understood the solution. You can find this whole code in the Git repository. I have given the link in the description. Thank you for watching this video. I hope you understood the application of recursive function in coding. Click in the top right corner to find more videos related to problem solving by Python Bytes. The link to the basic Python learning videos is available in the description below. All the coding done in the video is stored in the GitHub repository. The link is in the description. Please like this video and subscribe to the channel. Goodbye till next time. Keep coding.